Hi guys, it's me, Mr. Bertoch, your handsome science teacher extraordinaire. In this video, we're going to be talking about climate. Right now, as I record this video, it is actually raining outside. And weather, is something that we are all familiar with that has an impact on our lives. It affects our plans that we make and the things that we might do on the weekend. But weather is a limited phenomenon, and it's something that is short term. It's today's weather. We refer to what's today's weather, what's tomorrow's weather, what's next week's weather. Whereas climate is another term we use. It kind of refers to weather, except that it is talking about the weather in an area over many years, the averages. Climate refers to the expected averages in an area. So, for example, where I live here in West Virginia, it is a forest, and our climate is pretty predictable that in the summer it's going to get around 85 degrees and we're going to get a lot of rain. In the winter, it's going to get down into the 40s. It does get colder, but I'm talking about averages, right? And we're going to get a little bit of snow. Where I used to live in Utah, it got much hotter, had a hotter climate. You got up over 100 degrees in the summer, and it was very dry. And in the winter, it got very cold, much colder, and we got a lot of snow. It was a different climate. So weather is the day-to-day experience, what is actually happening in the atmosphere, whereas climate is the long-term averages in an area that are pretty much predictable. Okay, well, why are they predictable? Why is the climate in Utah hotter in the summer and colder in the winter than it is here in West Virginia? Why do we get so much more rain here than we got when I lived in Utah? Why is the rainforest the way it is? Okay, what makes an area, what gives it its climate? So that's what you're trying to understand by the end of this video, because you already know the difference between climate and weather, because we already talked about that. So now your goal is to understand why, what causes climate. And there are some factors that affect climate. A big one, in fact, the biggest one, is latitude. So if you look at a globe of the Earth, and you will notice that the Earth is round. I know you didn't realize that. Well, now you do. The Earth is round, and it has what we call latitude. The higher the Earth is spinning, and in the middle of it, there's this thing called the equator. And the higher, or the further, I should say, because you might be south or north, the further I get from the equator, the colder the temperature becomes. And the closer I get to the equator, the warmer the temperature becomes. So the furthest I can get from the equator, because then I start going back down the other side, are the poles. I can go to the North Pole and the South Pole, and they are freezing cold, right? And if I go to the equator, it's tropical. It's warm year-round. It's great weather. You could live in a swimsuit in the tropics, and if you tried to live in a swimsuit in the poles, you would freeze to death. Okay, so that's a big factor that affects climate, is latitude. And why? Why does latitude affect the climate? Well, what happens is that the sun is hitting the equator directly, straight on, and that warms it up. Whereas it's hitting the poles at an angle and you're getting much less sunlight. It's much more spread out across an area. And so it doesn't have the same ability to warm the poles that it has to warm the equator. Okay, so I can predict If a city is located further north or south, it's going to be cooler. If it's located towards the equator, it's going to be warmer. Okay, well, another important factor in climate is altitude or elevation. Two words that pretty much mean the same thing. Altitude or elevation mean how high an area is from sea level. The further or the closer I am to sea level, this kind of is the same concept. The closer I am to sea level, the warmer I am going to be. And the higher my elevation is, the higher I climb in altitude, the cooler it's going to be. This is why mountains are very often snow-capped. You can see like they're wearing snow hats, right? Beautiful, wonderful, stylish snow hats because it's cold at the top of the mountains. It might be really warm. In fact, Hawaii, which is a chain of islands in the Pacific Ocean, not exactly at the equator, but in the tropics, close, down closer to the equator than a lot of places where it's warm year round. Down at the base of Mauna Loa, which is a very tall mountain, it is summer year round. But if I climb Mauna Loa to the top, it's winter year round. It's cold at the top. There's actually snow at the top of Mauna Loa because it's such a high mountain. So altitude has an impact on climate. So when I am predicting the weather of an area, the climate of an area, I'm going to look at latitude, which is, again, how far from the equator it is. Further I am from the equator, the colder I'm going to be. I'm going to look at altitude or elevation, which is how high from sea level I am. Okay, and again, why? Why does altitude affect the temperature? Well, and this is a very complicated answer, which is really beyond the scope of what I want to cover here, but I'll just answer it briefly. That pressure, air pressure, has to do with what is going on. Okay, so at lower elevations, I have greater pressure. The air is squishing in tighter. That's why your ears pop. If you ever fly on an airplane or you travel from a place of high elevation to a place of low elevation, your ears pop because of the difference in elevation, and you might even get an earache. It's that squeezing and pressing of the air. So the more squishity-uppity the air is, the greater the temperature will be. The more spread out the air is, the lower the temperature is going to be. Less air pressure means lower temperature. So another impact that affects climate, because climate isn't just temperature. Climate is also rainfall, precipitation. You might have a cold temperature and get a lot of precipitation. You might have a cold temperature and it might be a desert, might be very dry. And you might have a really warm temperature that gets a lot of rain, or a place with a warm temperature that gets almost no rain, like a desert. Okay. So one thing that impacts that precipitation, not participation, precipitation is a mountain range, a large mountain range. Because what happens as a weather storm or as a weather system goes over a mountain range, the mountain range lifts it up through orthographic lifting, which is a big word you don't really need to remember, but it lifts it up. The storm system goes up and over the mountain, and as it does, the orthographic lifting, the clouds rise up and it squishes them like a sponge, squishes all the rain out of them. And so all the rain falls on one side of the mountain, and then you get to the other side of the mountain and the clouds are dry. There's no rain left. And so the other side of the mountain range is going to be a desert. And so this effect of a mountain range can create a really wet area on one side of the mountain range and what we call a rain shadow on the other side of the mountain range, which can extend actually for hundreds of miles. So you'll actually get a desert that will form because that mountain range causes all of the rain clouds to squish out their water, like squishing a sponge on the other side, on the first side of the mountain, and from where the storms come from. And on the other side, there is no water left. Okay, that's Utah. Where I used to live is a desert because of the Cascade Mountains. And Cascade Mountains along the coast of the western United States create a place that's really lush in like Washington and Oregon, where you get just buckets of rain. But then you get over the Cascade Mountains and it's very dry, and it extends for hundreds of miles all the way into Utah and Arizona and beyond. You have this vast desert, this arid region. So mountain ranges are one thing that impact and affect climate in terms of precipitation. Another more minor impact is vegetation. The Amazon rainforest has a lot of vegetation, right? And that rain, the rain that feeds that, comes in off of the ocean. But a lot of the rain actually comes from evaporation, and it evaporates or transpires out of the plants and creates rainstorms there. So that vegetation can have an impact, and it also can cool the temperature and can absorb water out of the ground. So the other thing is water. So water has a huge impact on temperature, because water has the capacities called specific heat capacity. It has the ability to absorb a lot of energy without changing the temperature of an area. And so what that does is water acts like a moderator of temperature. Where I have a lot of water, if I have like a body of water, like a lake or rain or even humidity, if I'm in a place that gets a lot of humidity or I'm near the ocean, that water will absorb and absorb and absorb like a battery charging, will absorb the sun's energy, and that will tend to keep it cooler. And then in the winter, it will release like a battery. It will release and release and release slowly the sun's energy, and that will tend to keep the winters from getting as cold. That's why where I live in West Virginia is cooler in the summer and warmer in the winter than Utah, where I used to live. Because Utah didn't have very much water. It was very dry because it's in a rain shadow from the Cascade Mountains. So it's very dry. There's very little water there. And so the sun energy comes in the summer, and there's no water to absorb all that heat. So the temperature spikes and it gets really hot in the desert, okay, in the day and in the summer. And then at night or winter, that heat just immediately just leaves, and there's no water to release energy back out into the nighttime or into the winter. So in deserts, you have more extreme temperatures because it's drier. Where I live now in West Virginia, it's humid and there's a lot of water. There's lakes and rivers, huge river, the Kanawha River that I live right next to, not too far away. And all of this water in the summer is absorbing energy, and so it's cooling the temperature. And then in the winter, it's releasing all of this energy that it had absorbed, and that moderates the temperature. So climate, again, is the long-term characteristics of an environment in terms of temperature and precipitation. It's impacted by latitude, by elevation, by mountain ranges that create deserts, by vegetation, and by bodies of water. Hi guys, thanks for watching my video. These rambling science videos where I go unscripted and just kind of barf up all the science knowledge out of my head are part of a series that go along with an online class that I teach, which you can sign up for if you go to handsomescienceteacher.com. I also have a whole bunch of free resources for homeschoolers. I have hundreds of articles on every topic that covers your entire science curriculum from 5th through 8th grade. I have online games and quizzes, all curated and written by this handsome guy, a science teacher with, well, three degrees, but 2 of them are in science. So it's targeted right to and directly to your science students. So sign up. Subscribe to the channel, and I release lots of videos. Also, in addition to these ones, lots of little short videos that are like 2 minutes long that cover science topics. Those ones you don't get to see my handsome face, but they're still good videos, and they're much more targeted, and those ones are scripted, so you don't have to hear me like you are right now going blah, blah, blah. The end. Subscribe. Thank you. Goodbye.